It's a new week, but not a new lesson. We're just going to continue lesson 1.5, where we were working on finding solutions to linear equations. The first thing we did was take a replacement value to see if it made a true statement. We then move on to looking at replacement sets, which says we're going to test more than one number. So we're going to take one number at a time, substitute the value of the variable d for each of these three values, and see if any of them make a true statement. And that would become my solution set. Starting this problem off, we're looking at replacing x with 0. So I'll have 4 times 1 plus, well, that's going to be 3 times 0, and then I'm going to see if that equals 28. Well, 3 times 0 is 0, and 0 plus 1 is 1. 4 times 1 is 4, and 4 does not equal 28, so 0 is not a solution. So looking at that replacement set right away, x, I can put a little x over there, that does not work. My second number to test is 1. I'm going to replace d with 1 this time. Using order of operations, let's simplify. 3 times 1 is 3. 3 plus 1 is 4. 4 times 4 is 16. And 16 does not equal 28. So 1 is not a solution. We might find out that this is an empty set. None of them are a solution, or we may just luck out with the last one. Let's try one more number. 4 times 1 plus 3 times 2. Does this one equal 28? Again, we simplify in the parentheses. This is 3 times 2 is 6. 6 plus 1 is 7. And 7 times 4 is 28. I have a solution. I can say that 2 is a solution to this equation. And that's all there is to the replacement sets. If I had to write it in set notation, I would just simply put 2 in the set braces. Okay, that's my solution. Now on to solving equations. To solve linear equations, we must isolate the variable. We're going to be solving one-step equations, two-step, multi-step, and then we're going to get into equations that have variables on both sides, which is a different level of solving equations. But if we do them in order, each one will build on the previous one. When we're isolating the variable, we may find out that we just have one solution, and that has been the case probably with almost all the equations you've already solved. But once we encounter this last type, variables on both sides, we're going to see that I could have no solution or infinite solution. Let's start solving. We'll start off easy. We'll go to the one step. Use the inverse operation to isolate the variable. Well, we know inverse is opposite, so if you see add, you'll subtract. If you see subtract, you'll add. If you see multiply, you'll divide. If you see divide, you'll multiply. Inverse. So in this one, and again, some people just write it directly underneath. I'm going to just expand it just a little for you to see. I'm going to subtract 4 on both sides. This cancels out, so because 4 minus 4 is 0. X is now equal to 7. Now that is my solution. Remember, I could always check it, because if I did 7 plus 4, we'll see that it checks. Once in a while, you may be asked to do the check. Now, sometimes when you're solving equations, I see people do this, and this is perfectly fine. You just below it put the inverse operation. Let's add 5 to both sides. In the first one, I expanded horizontally, and some people do it vertically. This cancels out. Anything plus its additive inverse is 0, so I got x by itself, which was my goal, and I get x is equal to 14. If I wanted to check, I'd do 14 minus 5, and I'd be sure that it equals 9. I now see a multiplication equation. I'm going to do the inverse. I'm going to divide. This is going to be a reminder of your signs, because when the signs are unlike, you get a negative quotient. And there we have -5. Well, let me check this. -3 times -5, does that equal positive 15? Yes, when the signs are the same, we get a positive product. On to the last one. This is a division. Inverse of division is multiplication. I'm going to multiply both sides by -2. It will cancel on the left, isolating the variable. Negative times negative gives me positive 8. And that's just a quick review of your one-step equations, but I'm pretty confident that we can all do these. Let's take a look at some two steps. In two steps, we have two possible things we're going to encounter. We could either need to perform two inverse operations, or we will be combining like terms first and then one inverse operation. Let's check a few of these out. Again, 3x minus 2 equals 19. Let me add 2 first. We always isolate everything. We always remove everything away from the x by the addition subtraction part first. That leaves me with 3x is equal to 21. Now I have one inverse operation left, and that's to divide, and I get x is equal to 7. Again, let me just do a little mental check. 7 times 3 is 21, minus 2 is 19. On to the second problem. I see addition, so I will subtract. Once in a while, you're going to get something that doesn't come out to a whole number, and I wanted you to see this right away, that sometimes you will get either a fraction or an improper fraction, and there's nothing wrong with that. It's still a real number. It's still a solution. If I plug that in, I will get the answer that I'm looking for. The last problem. This one tells me I need to combine like terms first. This will give me 4x is equal to 16. Now one inverse operation, and I get a solution of x is equal to 4. Once again, if I take the time out and take 4 times 9 to get 36, and 5 times 4 is 20, and I take 20 from 36, it will give me 16. We'll move on to the multi-step ones, possibly in person today, if not in our next section. I'll see you in class.